So ionic radius. Ionic radius. What is actually ionic radius? We can say that it is a distance between the nucleus and the outermost shells of an electrons, means outermost electrons of an ions. Okay. For example, if I'm talking about this is Na positive is an ion. So its electron configuration is 281. But when it lose one electron, it will form Na2 positive, Na positive. So what is actually, if I talk about this one, that it is a distance. Ionic radius means it is used for ions. It is used for ions. Okay, and we can say that it is the distance. It is the distance between the center of nucleus. It is the distance distance between center of nucleus and outermost electron in an atom. Okay, sorry, in an ion. It is known as ionic radius. Got it? So if I talk about that, there are the two types of ions, you know. So ionic radius is of two types. Ionic radius is of two types, or we have divided it into two parts. One is the cationic radius, and the second one is anionic radius. Got it? Got it? Cationic radius means it is always, cation means which is positively charged. Okay. So if I talk about this one, that it is always smaller than the parental atom. Cationic radius is always smaller than the parental. For example, if I'm talking about this is Na positive and this is Na. So this it's the parental atom of Na positive is Na. So it is always means if I talk about that which one is going to have the more radius. So this will be going to have more radius and this will be going to have less radius. Got it? Why? Because greater number of protons are attracting the lesser number of electrons. Okay. Okay. Understood this one? So we can say that uh, it is it is always smaller than parental atom. Okay. And if I talk about this anionic radius, and it is always greater. Is always greater than its parental atom. Okay. Noted this one. For example, if I talk about which one is greater, if Na is greater, Na is greater, or Na positive is greater. So Na is greater. Okay. And if I talk about which one is greater, Cl minus is greater or Cl is greater, so Cl minus is greater. Got it? Got it?
Yes, sir.
Reason? What is the reason?
Yes.
Greater number of protons are attracting the lesser number of electrons. So atom size will shrink. Got it? Got it? So you can write the reason here. The effective nuclear force, the effective nuclear force of cation is greater than parental atom. And what is here? The effective nuclear force of anion is lesser than than its parental atom. Okay. So we can say that if M is greater than M1 greater than M2 greater than M3. In here, M3 minus is greater than M2 minus is greater than M1 minus greater than M. Noted?
Yes, sir.
So if I talk about that, what is the difference? Okay, relationship between the ionic radius and the nuclear charge. So if I talk about that, always a cation is always smaller than the parental atom than the ionic radius. So if I talk about this one, that if the nuclear charge means we can say that ionic radius is always inversely proportional to the nuclear charge. For example, if I talk about this one, the relationship between ionic radius, ionic radius and nuclear charge, nuclear charge. So if I talk about this one, that Cl minus will be always greater than Cl, its parental atom, and Cl will be always greater than Cl positive. Got it? So this is the order of radius. Order of radius. Got it? And if I talk about which is going to have highest positive charge or the nuclear charge, the nucleus, the nuclear charge, we can say that this Cl minus is going to have the least nuclear charge because here it is going to have 17 proton and here it is going to have 18 electrons. So the nuclear charge is less in this one. Then we have 17 proton, 17 electron, and then we have 7 Cl positive, 17 proton, and 16 electron. So if I talk about this one, that the nuclear charge is maximum in this one. Okay, order of nuclear charge. So of of nuclear order of nuclear charge. So we can simply say that ionic radius is inversely proportional to nuclear charge. Okay, nuclear charge means positive charge. Actually, we are talking about. Okay, got it? Because nucleus has positive charge. Got it? Done?
Yes, sir.
So
Yeah.
let's have a question. The metallic radius, radius, and 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 covalent radius. Radius of K and F, potassium and fluorines are 1.80 angstrom and 0.80 angstrom respectively. Okay, then ionic radius of K and F are ionic radius of K and F are number one is 0.80 angstrom and 0.90 angstrom respectively. Second option is 1.90 angstrom and 0.70 angstrom respectively. Third option is 1.70 angstrom and 0.90 angstrom respectively. And the fourth option is 1.7. Fourth option is none of these. Tell me which one is what it's saying. The metallic radius and the covalent radius of potassium. Potassium is metal, so it will be going to have the metallic radius, and fluorine is a non-metal, so it will be going to have the covalent radius. Okay, so it is being given to you that the metallic radius of potassium is is 0.80 angstrom, and that of fluorine is going to have 0.1.80 angstrom. Okay, then tell me which one is going to have the metallic radius, highest metallic radius. Which one is going to have the means ionic radius of potassium and fluorine are? Tell me what are the ionic radius of fluorine and tell me fast. Tell me. No, it's easy. Lena, are you there? Both.
Yes, sir.
Yes.
So you can expect here that the ionic radius of potassium. Just a minute, let it plug in the charger. You can imagine this is very simple. You know that potassium is going to have hmm, potassium is going to have means its ion will be K positive na, and K positive will be always smaller than this one, this 80. So it will be less than 0.80, and fluorine form F minus. So its ions is F minus, so it will be greater than 1.80. So which two situation are means which we need less than 1.80, okay, and greater than 1.80. So here then the ionic radius of potassium. Oh, I have written I've written a little bit. This is the respectively. It is saying that 1.80 is for the potassium. So I've just written it wrong. So this is for potassium. Okay, 1.80 is for potassium, and this one is for 0.80 is for this one. So it should be greater than this one. So greater than this one is this one, and lesser than 180. So this option is the correct option. Na? Third, it is less than, okay, 1.80, 1.70, and it should be greater than 1.80. Got it? You
Yes,
Yes.
sir.
understood? Both understood?
Yes, sir.
Now let's move to the next part here.
Yes.
We have a next question that in which compound chromium means we can say the smallest ion of chromium is in which of the following compound the smallest chromium will be. So in which which of the in which of the following compound chromium ion is smallest is smallest. Okay, option 1 is K2, chromium chromatine Cr2O3. Okay, here chromium is going to have +3 charge. The second is Cr2 CrO. Here chromium is going to have +2 charge. Third is CrO2. Here chromium is going to have +4 charge. Okay, and the fourth one is K2Cr2O7. Here chromium is going to have +6 charge. Tell me which of the following in the chromium is going to have the lowest size or the smallest size. Tell me, this is simple. Hmm? Lena? No, huh? What we have learned, the nuclear charge is inversely proportional to atomic size. And nuclear charge is actually positive charge we are talking about, positive charge, okay? So greater the nuclear charge, smaller will be the size. So in this, the chromium is going to have +6 charge. So this will be going to, this is simple. Why are you not getting this one? The next question. Are you there? Why are you not replying? Ionic radius of Na is 0.802 angstrom. Then metallic radius of Na is option A 0.25, option B is 1.108, sorry, 0.108, option C is 0.218, and option D is none of these. Tell me which one is the correct? Please turn on your camera. Are you studying? Or are you doing something else? Noha, Lena, turn on your camera, please. Turn on your camera. Noha, we're just taking your extra class on Friday. Just keep this. Why are you not responding? Are you there?
Sir, I'm solving.
You're solving. Okay, then solve. Tell me. The ionic radius is given to you. The metallic radius is being asked. Will it be greater or smaller? Will it be greater or smaller? Tell me first. Tell me. Ionic radius is given to you of sodium. Will it be greater or smaller than 208? Tell me. Are you concentratedly studying or not?
It'll be lesser.
It will be lesser. No, ionic radius is given to you, means Na positive radius is given to you. So this is given to you 0.208 angstrom. So Na will have more radius because it is the ionic form. Positive means more positive charge, more will be the smaller size. So this you can say, okay, this Na is going to have the greater charge than this one. Okay, so these two are smaller. This is only the greater, which is approximately equal. Got it? Got it?
Yes.
Next is, if I talk about that is the size of isoelectronic species. Size of isoelectronic species. Okay. So we can say that a species having similar, what is isoelectronic species? Isoelectronic species are the species that has the same number or total number of electrons are same. They are considered to be as isoelectronic species. For example, O minus 2, Na positive, okay, and we can say that Mg2 positive, okay, neon, they are all isoelectronic species. They all have 10 electron in their total number of 10 electrons. Because oxygen has electronic configuration 2 comma 6, but it borrow 2 electron. Because of that, it's going to have minus 2 charge, so it will be 10 electrons. Similarly, Na is going to have 281, but when it going to have Na positive, it will lose 1 electron and it will have 28. So this is all, they are going to have the same number of electrons. Got it? Isoelectronic species. So we can say that a species having similar total number of electrons are called isoelectronic species. Isoelectronic species. Got it? Understood? Understood? For example, if I talk about that O minus 2, F minus, Na positive, Al3 positive, neon. Okay. So these are all isoelectronic species. Got it? So if I talk about the size, how the size varies actually. So we can say the size of isoelectronic species depends on the nuclear or Z effect. Okay. Got it? So we need to write here that the of the size of the isoelectronic species depends upon Z upon E, where Z is electronic. Okay, but the value of Z upon E value. Okay, Z upon E value. We can say that size is inversely proportional to 1 upon Z upon E. Okay, where Z is the atomic number. Okay, or we can say that number of proton, number of proton and E is the number of electron. Okay, got it? The more the value of, we can say that is inversely proportional to Z upon E. Got it? Got it?
Yes.
Or we can write it, the size is inversely proportional to proton upon electron. Okay, the ratio of proton to electrons. So if I talk about the size, you know that if I talk about this one, that we have order radius. For example, if you have a question here, for example, order radius for O minus 2, F minus, Na positive, and Al3 positive. Got it? So if I talk about this one, that if we have Z upon, here we have total number of proton is 8, and here it is going to have 10. It is going to have how much? 9 by 10. It is going to have how much? The size is atomic number is 11 and the number of electron is 10, and this is also going to have the number 13 and the number of electron is 10. So we'll find that it is going to have 0.8, then it is going to have 0.9, then it is going to have 1.1, this is going to have 1.3. So we can simply say here that the size is inversely proportional to this value. So we can say that more this value, lesser will be the size. Got it? More this value, lesser will be the size. We have written that size of isoelectronic species, isoelectronic size of isoelectronic species is inversely proportional to proton to electrons ratio. Okay, proton to electron ratio. Inversely proportional means if this value is more, then lesser will be the size of that. Okay, got it? So we can say that the greater size of the atom will be O minus 2. Then we're going to have F minus. Then we're going to have Na positive. And then finally we're going to have Al3 positive. Got it? This will be the smaller size, because there are greater number of protons are attracting the lesser number. So here you can see that 8 proton are attracting the 10 electrons. Here 9 protons are attracting the 10 electron. Here 11 proton are attracting the 10 electron. Here the 13 protons are attracting the 10 electrons. So all of them are attracting the more the positive charge, more will be the attraction power, and the smaller will be the size. Got it? So here more the positive charge, greater will be the attraction fraction and lesser will be the size, and lesser will be the size. You understood this one?
Yes, sir.
Okay. Okay. Now if I talk about, let's take a question here. Consider the following condition or following information. Following information. Consider the following informations. We have ions here, we have radius here, okay, in angstrom. So we have P minus 3, we have S minus 2, okay. And then third, we have Cl minus, then we have Ca2 positive. And we have here 0, then we have 0.8 angstrom, then we have 0.60 angstrom, then we have, okay, no, wait a minute. We're going to have 0.80 angstrom here. And then we'll have 0.60 angstrom, then we are going to have 0.40 angstrom, and then finally we have 0.20 angstrom. Okay, got it? Phosphorus 3 negative, then sulfur 2 minus, then chlorine 2 minus, and then Ca2 positive. Now, on the basis of given information, okay, ionic radius of potassium will be, tell me. Option, I'm going to give you the option here. Option A is 0.90 angstrom. Option B is 0.70 angstrom. Option C is 0.50 angstrom, and option D is 0.30 angstrom. Tell me. Potassium will lie here. And they ask potassium ion. Tell me. Noha and Lena, tell me. Tell me fast. Which of the following can you guess on the basis
Option
of
D.
option D?
D.
Yeah. Option D is correct because it will lie here. Okay. Potassium will lie here. So D is the correct option. Next. Now let's move to the done this one, Lena, and you know noted.
Yes. Yes, sir.
Let's move further. Value based order of, now next topic is value based order of metallic and ionic radii of S block elements. Okay. And what is this value based? We need to understand that value based order means order we have to arrange them, means arranging order of this uh, S block elements we are talking about. So for example, we have lithium, then we have sodium, then we have potassium, then we have rubidium, then we have cesium. And then here we have beryllium, then we have magnesium, then we have calcium, strontium, and then barium. Okay. So this is the alkali metals and earth alkali metals. So if you know that if we go from left to right, the size of the atom decreases. Why? Because the same greater number of proton, as you know, means then since the charge is the shell is same, since the charge opposite charge are increasing, so size of the atoms are continuously decreasing. For example, if I talk about that here lithium, beryllium, boron, carbon, nitrogen, oxygen. So this is electron configuration is 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. So here there are 8 proton and 8 electrons are attracting. Here 7 proton, 7 electron, here 6 proton, 6 electron. So as we move from left to right, the number of electron and proton increases. So there is charge due to increase in charges, the size of the atom keep on decreasing. Okay, the size of the atom keep on decreasing due to greater number of electrons. Okay, a number of electrons and protons. So the size of the atom keep on decreasing. Okay, and as we move down the group, the size of the atom increases. Why? Because every time we going to have an extra shell is added. This is going to have 2 comma 1, then 2 8 1, then 2 8 8 8 1, then 2 8 18 8 1, then 2 8 18 18 8 1. So this way, this is how the electronic configurations means how it is added. Okay, are you getting this point? Are you getting?
Yes, sir.
So here we can simply say here that this is the lithium, beryllium, boron, carbon, nitrogen, oxygen, and this is how can you arrange them? So first of all, this is going to have the height, which is going to have the smallest radius. So this one is going to have the smallest. Then this is bigger than this one. Then again come to this. Then come to this. Okay. After the lithium, then sodium and magnesium is going to have bigger radius. But if we select which one is going to have the smaller, the magnesium is going to have a smaller. Then we have this one. Then again an extra shell is added. So this is the size of this one. Then again this will goes here. And this keep on. Okay, now as we move from potassium, okay, after the calcium, okay, this calcium and we can say that beryllium, they are going to have almost same size. We can say that calcium, strontium, and barium, they are going to have almost same size due to inert pair effect we will going to discuss. Okay, and then the size of the atom increases like this. Got it? Got it?
Yes, sir.
Largest size atom is cesium. So this is the largest in the whole periodic table. Largest size atom. Got it? And similarly, if I talk about their ions, if I talk about their ions, so ions is going to have the same pattern. Okay, for example, if I talk about that, which is going to have the maximum. So here we have beryllium, lithium, beryllium, magnesium. Okay, then we have beryllium 2 positive. Okay, then beryllium 2 positive and magnesium 2 positive. Okay, so here we will have beryllium, then we will have magnesium. So if I talk about this is going to have the smallest size. Then if I talk about their isoelectronic species, okay, isoelectronic, let it be. We'll discuss this one later. Okay, so let's move to the next question here. Just imagine and have a question here. Have you noted this one?
Yes, sir.
Next is consider the following information. Radius, we can say the radius of Li and radius of Be is equals to P. Okay. Radius of Na and radius of Li is equals to Q. Radius of K and radius of Na is R. Got it? On the basis of the information, on the basis of above information, okay, which is correct, which is correct relation between PQR. First of all, if I talk about that one, that K, if I write about that, K is greater than Ba. Ba is greater than strontium, is greater than calcium. Okay. Or let it be. Let it be. We have given this information to you. Now note it down. The first option is P is greater than Q is greater than R. The second option is R is greater than Q is greater than P. Third option is Q is greater than P is greater than R. And the fourth option is R is greater than P is greater than Q. Which one is the correct option? So you can write the table here. है ही ना करे रब से फरियाद और so this is the smallest, then this one, then this one, then this one, then this one. Okay, then this one, then this one, then this one. Okay, so tell me. Now you can take the information here. Radius of Li and beryllium is
Option 3.
P. Okay, and Na, and here Na and Li is Na and Li is Q. Okay, and K and radius of K and Na is R, which is correct. Option second. Yes, radius of K should be greater than Q should be greater than P. Got it? You understood?
Yes, sir.
Okay. So here you can understood by this one. Okay. Now write down the order of this one also. Order of this one, that order. This is an important that if we have the ions, like we have beryllium 2 positive and magnesium 2 positive. So if both are 2 positive, like so we will going to have beryllium is the smallest. Okay. Then after we have magnesium, then we have lithium. Okay, then you have to memorize this one. Okay, lithium has 2 comma lithium 1 positive. Okay, then we have calcium Ca2 positive. Then we have sodium 1 positive. Okay, and then we have strontium 2 positive, beryllium 2 positive. Okay, and then we're going to have potassium, rubidium, and cesium. Like we have the value of this one. Okay, so you need to keep in mind that how their order is. The radius of beryllium is the smallest. This is the smallest in all, the smallest. And if we are just going to have this it cationic form, positively charged. Okay, so this is the smallest, and this is the, we can say, the largest. You can feel here that if there is a 2 positive charge and they both are going to have 2 positive charge, same positive charge is there, so we will give the preference to the, just keep in mind, just listen to me carefully, that if I'm just going to give that this is going to have electronic configuration 2, this is going to have 2 8, this is going to have 2 lithium. Okay, then it is going to have 2 8 8. So, and this is going to have 2 8 only. Okay, so you need to keep in mind that if we have 2 positive charge and if we have 1 positive charge, so the extra shell will not give you the means this is the lithium 1 positive and this is the magnesium 2 positive. 2 positive will be given more preference. One positive charge, one extra positive charge, even if it is going to have 2 shell, okay, then it will be smaller than the one which is going to have only 2 electrons but with one single positive charge. Got it? Got it? So you need to
Yes,
keep
sir.
in mind that now this is positive. Now another, if I talk about the next, so this is going to have 3 shell, but it is going to have 2 positive charge. So it will be given more preference. Then, okay, then this one, again, the single charge, but 2 shells. Got it? So this is the way that you need to keep in mind that how we are going to have this one. Okay? Understood?
Yes, sir.
So here we have another one. So it is the question number with ionic radius of Li Be2 positive, Na1 positive and Mg2 positive are respectively given to you. That the first option is 0.80 angstrom, the second option is 0.6 angstrom, third option is 0.4 angstrom, and the fifth option. Here this is the first. The second one is 0.20 angstrom, then 0.40 angstrom, then 0.60 angstrom, and then we have 8.0 angstrom. Then we have third option as 0.60 angstrom, then 0.20 angstrom, then 0.80 angstrom, and then 0.40 angstrom. And the fourth option is 0.60 angstrom, then 0.20 angstrom, and we have 0.40, 0.40 angstrom, and then we have 0.80 angstrom. And tell me, tonic radius of lithium, beryllium, respectively, you need to tell me. So first arrange them. First arrange them. Respectively, they are going to have. So this is the smallest. Be2 positive is the smallest. Then after, it is going to have 2. Got it? Got it? Then we have magnesium 2 positive. It is going to have 2, 8. Then we have lithium 1 positive. It is going to have 2. And then we are going to have Na1 positive, which is going to have 2, 8 electronic configuration. Okay. So this is the first one. This is the second one. This is the third one. So no, not the second one. This is the second one. This is the first one. This is second one. This is the third one, and this is the fourth one. So you need to keep in mind here that arrange them. Though beryllium should be smaller. This one, this should be the smallest. In which this is the smallest. This one in this one, and this one is the smallest. The second smallest should be magnesium. So this is the second smallest. Okay, here second smallest. Then we have the third, this one. So C is the correct option. Got it?
Yes, sir.
Noted this one. Noted.
Yes.
The next one is factor affecting the atomic size. Next topic is factor affecting the atomic size. Okay, first one we are going to have that number of shells. Number of shells. Number of shells. If the number of shell increases, then we will say that the size will increases. Okay, so this arrow increase indicate that increase in size. Got it?
Yes,
Got
sir.
it? Next, we're going to have this. Next is atomic size. The second one is, we can say that more the atomic size, atomic size is directly proportional to number of shells. Got it? The second option is effective nuclear charge. Okay, that is called Z effect. Okay, so we can say that if the Z effect is more, then Z effect lesser will be the means this atomic size will decreases. So we can say that if the more the positive like charge is there, the atomic size will decrease. So we can say that atomic size is inversely proportional to Z effect. Got it? Got it? Third one is the
Yes.
screening effect, or we can tell shielding effect. Noted this one?
Yes.
You also know her?
Yes, sir.
The next one is AC is screening effect. Screening effect or shielding effect. Shielding effect. So if I talk about the shielding effect, means sigma that we have given, shielding effect is measured with sigma that we have done in the previous class. Okay. So more the shielding, if more the sigma, the value of sigma, okay, more will be the shielding effect. Okay. So we can say that distance between center of nucleus and outermost electron. Okay. More the shielding effect, we can say that more will be this one. Okay. Atomic size will increases. So we will say that atomic size is directly proportional to sigma. Got it?
Yes, sir.
So we have discussed this one and we have done this one. So let's take some numerical. Just a minute. How we are able to calculate the the value of sigma? What was the formula for the sigma that we were just discussing for the shielding effect, effective nuclear charge? Hmm? How we are able to calculate the value of sigma? You forgot, or you still remember? Tell me what was the formula that we have written. Check in your notes. For F and D block element we have different formula, and for S and P block elements we have different formula. So what was the formula? Do you remember that one?
Number of electrons in the outer shell minus 1
Yes.
times 0.35 plus
Number
number
of
of
electrons.
electrons
Yes, in outer shell. In outer shell
in
minus
the
1.
penultimate shell.
In the outer shell minus 1 into 0.35 plus number of electrons in the penultimate shell shell. Okay, number of electrons in the penultimate shell into 0.85 and plus rest of electrons. You have this formula, rest of electrons. Got it? Got it?
Yes.
So how we can discuss this one? So this is very important. Now let's discuss. So let's have a numerical on this one. And what was the another formula? What was another formula for the, this was for the S and P block. And what is the formula for F and D block? Number of electrons electron in D or F subshell only. -1, okay, into 0.35 plus rest of the electron before D or F subshell. Before D or F subshells. Okay. Got it? For example,
Yes, sir.
if we need to calculate the value of Na, okay, we need to calculate the value of Na. Calculate the value of, for example, calculate the value of Na, value of sigma n of Na. Tell me what should be the value of this one. We have done so many numerical problems on this one in the previous class we have discussed. Tell me. Tell me, what's the electronic configuration of Na? 1s2, 2s2, 2p6, 3s. Tell me. Tell me, this is very simple. 1s2, 2s2, 3s1. And now the outermost shell's electron is going to have 1. So you will write number of this because this is S block element. So we'll write number of electron in outermost shell. This is the third is the outermost shell. So we'll write 1 minus 1, 0 into 0.35. Okay, then plus number of electron in the penultimate shell. The penultimate shell means the previous shell. The previous shell is the second shell. There are 8 electrons into 0.85 plus rest of the electrons. The rest of the electrons are 2 only. Got it? So I give you that when we multiply this 8 with 0.85, we will get 6.80 plus 2, you will get 8.80. Got it?
Yes.
And the next, similarly, for the D block elements, if we need to calculate, let's you calculate for scandium the value of sigma for 21st electron of scandium. Tell me. So for this, you need to keep in mind, we have written a note that you have to always arrange the element. Actually, electronic configuration, you need not to write. You have to write the electronic configuration in the proper order. 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, then 3d. 3d1 we used to write like this way. Okay. But this will reach to this one and this will comes here. We have to arrange it according to the order. 1s2, 2s2, 2p6, then 3s2, then 3p6, then 3d1. Okay, this 4s2 will come here. This will not be included. Okay, then what we does? We does the number of electron in D or F. This is 1 minus 1. So there is only D. In DF subcell is going to be only 1. Then into 0.085, sorry, 0.85, 85 into, then what we does? Tell me. Sorry, 0.35, not 85. 0.35. Then what we does? Tell me fast. And plus the number of electrons. Okay. So what is the formula? Rest of the electron we have to add before DNF. Before DNF. Okay. So how many electrons are there before DNF? 18. So this will be 0 into 0.35. We have 18 electrons. Got it? Got it? This is the way how we calculate the screening effect. Okay. Sigma. You understood?
Yes.
Yes, sir.
Both. So when you practice, yes, Noah, Noah were absent in the previous class, na?
Yes, sir.
So Noah, you need to, it means it is must for you that you need to watch the video, okay? Otherwise, this screening effect, the important question that we were discussing, you will miss that one. Okay?
Okay, sir.
Okay. Now the next one is, if I talk about the factor affecting, we are discussing the factor affecting. Here, screening effect we have done. Screening effect means sigma. Okay. So more the screening effect, more will be the atomic size. Okay. Got it? Now the next one is periodicity in atomic size. Means repetition of same atomic size. So periodicity, this is important. Periodicity in atomic size. In atomic size. So if I talk about the periodicity, so we have this positive shell, okay, and then we have this one. This is 1s1, sorry, 1s2, and this is 2s2 shell, 2s1. Okay, this is lithium. Second, beryllium, and then we are talking about the iodine. We are just talking about the fluorine. Fluorine. Okay. So this is the fourth one. Beryllium is going to have 4, and it is going to have 1s2 and then 2s2. And that of fluorine, if I talk about the electronic configuration of fluorine, is 1s2. Then we have in fluorine, we have 2s2 and 2p5. Got it? Got it? So if I talk about the effective shielding in this one, shielding means these are the 2 electrons here, these are the 2 electrons, okay, these are second electrons. So if I talk about that, effective shielding is the reason that means almost we know that they are going to have the similar size. As we know from left to right, the size of the atom keep on decreasing. Okay, so note it down here. Effective shielding. Okay, so they are almost going to have this, means they are almost, if I talk about that, effective shielding is done by this 2 electrons, this two electrons. So they are just shielding here. So they are also just shielding here, and they are also just shielding here. The 2 electrons are shielding. So the inner 2 electrons are shielding okay, these 2 electrons are only shielding the electrons. The inner electron shielding means, the effective shielding is done by 2 electrons. Okay. Are you getting my point? These 2 electrons are doing effective shielding. Okay, the inner 2 electrons are doing the effective shieldings. Okay, so we can say that since the number of shells remain constant, so if the number of shells remain constant, then they will be neglected. Okay, so how can we say that here the effective shielding and effective shielding is also constant, number of shells is also constant? Then what is going to tell you that the charge, okay, what is making this size decreasing? So we can keep it here, that as we move from left to right, we can say that here effective shielding and number of shells are constant. Why? Because this is shielded by the 2 electrons only, and inner 2 electrons. Now if we talk about that, as we move from left to right along the period, then what is increasing? The z effect is increasing, means the nucleus is increasing, because it is going to have 3 protons, it is going to have 4 protons, it is going to have 9 protons. So the effective nuclear charge is increasing. So if the z effect increases, then the atomic size will decreases. Okay, atomic size will decreases. Got it? You understood?
Yes, sir.
So we can say that in the horizontal lines, the inert gas is the largest in size. You need to keep in mind here that as we move from left to right, the size of the atom increases. But if we talk about the horizontal line, means in along the group, the inert gas are in the largest in size. So that's why we just in the periodic table we just keep the inert gas on the left hand side, but actually they are the zero group. They should be kept here. They are the biggest in size. Okay, okay, got it. So you need to keep in mind here that this is very important, that in a horizontal line, or we can say that along a period, from left to right, okay, inert gas are largest in size. Okay, largest in size. For example, if I talk about that, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. As we move from left to right, the size of the atom will keep on decreasing. The size of the atom will keep on decreasing. Okay. Keep on decreasing. But here after we have here neon, then the size of the atom will again increases. Got it? So this neon is going to have the largest size because it has completely filled shell. Got it? Understood?
Yes.
So this is the largest in size. You need to remember this one. Why? Because inert gas, what is the reason behind this one is because here we just calculate the covalent radius. And covalent radius, and the metallic radius we just calculating. So for this, we just calculating the fluorine. We don't have, we are not going to have fluorine as the means fluorine as we cannot find the fluorine atom. Fluorine exists in the form of F2. So we will have one fluorine atom like this, another fluorine atom like this. So their covalent radius are measured. Okay, and since the covalent bond is formed, the atoms actually overlap each other. Okay, so their nucleus come closer to it. So this is the average distance. So here we're going to have this one. Actually we are just measuring the radius up to here, not up to here. But in case of neon is an inert gas. It does not exist in the form of Ne2, okay, or He2. So it does not exist. So we just have one neon atom here and another neon atom here. So we just calculate this distance and van der Waals radius, this one divided by 2, and again further we will going to have this. So we'll say that because van der Waals radius is calculated, the reason behind this is that van der Waals radius is calculated for inert gas. Got it? For inert gases. Understood? Noted this one?
Yes, sir.
Okay. Next. So we can have like this neon, then we have lithium, then we have beryllium, boron, carbon, nitrogen, oxygen, fluorine. Next, in a group, if I talk about along a group, in a group, if I talk about from top to bottom, as we know that the size of the atom increases, so number of shell increases. But we know that the number of shell, along with the number of shells, sometimes inert pair effect plays an important role, where the size of the atoms almost remains same as we go from from top to bottom. So here we can say that number of shell, as we go from top to bottom, the number of shell increases. Number of shell increases. Okay, got it? Then the atomic size will also increases. Got it? And here Z effect, if the Z effect means the number of electron is also increasing, proton charge is also increasing as we go. Sodium is going to have 11 proton. As we go below it, is potassium is 19 proton is there. So Z effect is also increasing. So when Z effect increases, then size of the atom decreases because the positive means the number of electron and protons are increasing. So we can say the Z effect increases. Okay. So if the Z effect is increased, so it will balance each other. But since the screening effect is also increased, as we move, okay, let me explain you that the Z effect increases, the size decreases. Okay, so they will counterbalance each other. As we move from left top to bottom, so one thing is increasing the size, another thing is decreasing the size. So the ratio, we can say that they can counterbalance. Okay, now we need to move it here each other, that since the Z effect is increasing, the atomic size is decreasing. But along with the screening effect also increases. The screening effect means, and we know that screening effect is directly proportional to the atomic size. So this thing is decreasing the atomic size, but the screening effect also increases. And what is the screening effect? Let me explain you one more time what is screening effect. That for example, this we am having the sodium atoms. So sodium atom is going to have electronic configuration 1s2, then 2s2, and then 2p6, and then 3s1. 3s1. So these electrons, this is the outermost shell electron, and it is going to have 3s1 here. Okay, so these are shielding. These are shielding the electron. This means this positive charge of nucleus is shielded by this electron because they are revolving around it and they are shielding. They are not allowing the positive charge to reach there because they are just shielding this one. And if we are just going to have potassium, this is 2s2, 2p6, then we have 3s2, 3s2, 3p6. Okay, then we will going to have 4s1. Okay, so here the electronic configuration of potassium is 2881. So this here the screening is done by this one and this one also. And so here the 3 shells are screening, here the 2 shells are screening. So as we move, as the shells are increasing, but the screening effect is also increasing. And this screening effect prohibits the positive charge that is reaching to the outermost shell's electrons, and this due to that the size of the atom increases. So we know that if the screening effect increases, screening effect increases, then atomic size also increases. You understood this one? Understood this one?
Yes, sir.
Okay. So here we need to note it down. So here number of shell increases and due to the atomic size increasing. But here the Z effect increases. But along this Z effect, the screening effect, though this is decrease, this property is decreasing the size. But since the screening effect also increases, so screening effect increases the size. So these two will counterbalance each other. So, but just the net effect is this one. Net effect is due to this one. So we can say here that here the screening effect increases. So we can say that this increases size, increases the size. So, but these two properties counterbalance each other. Okay, they do cancel out each other. We can say that increases in same ratio. That's why balanced each other. Got it? And you have to note it down that the net result is that the atomic size increases. Got it? They are just cancelling out each other, but the two things are increasing the size. The one thing is decreasing the size. So the things we can say that overall the size of the atom increases as we go down the group. Got it?
Yes, sir.
But if they are having charge, like if they are having charge, like in the previous one, we are having beryllium 2 positive, and then after we are going to have magnesium 2 positive, and then we have lithium 1 positive, then we have sodium 1 positive. The size of the atom you can see here, that is going to have 2 shells, this is going to have 2 8, still this is going to have 2 shells, but the charge, due to charge, and it is going to have only 2, this is going to have only 1 charge, and having only 1 shell, still the size of this one is smaller, it has 2 shells. So when they are going to have the charges, then we have to keep in mind that there is something we need to keep in mind. So atoms, if they are having charge, okay, if the atoms are similar, we can say that atoms if the similar atoms have different charge, if the similar atoms have different charge, okay, like we have P3 positive, then P5, then P, and then P minus 3, okay, then we have P, then if they are going to have similar atom and they are going to have the different charges, P3, then P5, then P and P3. The order of this one is P3 is greater than P is greater than P3 positive, and then P5 positive. Got it? This will be going to have the, means more the charge, positive charge, more smaller the size. Okay. And if second rule is, if the atoms are different, if the atoms are different, okay, for example, if we have different atoms, and these different atoms are actually, if I talk about here, that the some atoms may be isoelectronic, some atoms may not be isoelectronic. So first of all, what we need to do here is that if the atoms are different, then first count their number of electrons. Okay, atoms are different, then count their number of electrons, then count their number of electrons. Okay, then count their number of electrons. Are you getting? And after you find that some of them may be isoelectronic, most probably they may going to have the, and if they are going to have isoelectronic species, if they are isoelectronic species, okay, like we are talking about argon, okay, potassium 1, like sulfide minus 2, like Ca2 positive, calcium, they are going to have 18 electrons. So they can be arranged, you know that the number of proton is in which they are going to have more, they will be going to have more smaller size. So here they are going to have 18, but this is going to have 20 proton, this is going to have 16 proton, this is going to have 19 proton, this is going to have 18 proton. So this will be the smaller, this will be the second one, this will be the third one, and this will be the fourth one, this will be the biggest. Got it? Got it? If they are isoelectronic, then the one which is going to have more number of proton will be going to be the greater in size. So we can say here that sulfide minus 2 will be greater than, this is the biggest one. Then after we're going to have argon. Then after argon we're going to have potassium, and then we're going to have Ca2 positive. Got it?
Yes, sir.
And if we are going to have, let's talk. And if all these means are not working, then what you will do? If all of them are not working, then means neither it is isoelectronic nor it is the same element which is going to have different charges. Okay, then what you will do? Okay, then there is a means you need to give the preference that the electrons are 1 or 2 in the first shell, then 3 to 10 in the second shell, You let it be. Should I give you this question? Okay. Let it be. Let's have a question first. Okay. Let me teach you this one also. We need to calculate the number of shells. Okay. So if all is not working, let's suppose it is neither isoelectronic nor it is the same element with different charges. Okay. Then what we'll do, we'll count the number of electrons and number of shells. Then if nothing is working, neither the elements, i.e. neither the element neither the element means ions or atom is same nor isoelectronic. Then we will count the number of shells. Okay. Then we will count the number of shells. We'll count the number of shells. Like number of electrons here, and here we're going to have shells. So if we have 1 or 2 electrons, there will be 1 shells. If we have 3 to 10 electrons total, then we will have 2 shells. Okay. Then 11 to 18 comes in the third shell. Okay. Then 19 to 36 comes in the fourth shell. And then 37 to 54 come in the fifth shell. And they are going to have 5 cells. And if the atomic number is between 55 to 86, then it is going to have 6 shells. Got it? Got it?
Yes.
And if you're talking about that, more shell species is always greater than the less shell species if they don't have the charges. Okay. So we will say that more shell species. So note it down. More shell species will be greater in size. Than less shell species. Got it? Like for example, if I'm talking about lithium, aluminium, cesium, and strontium. And here their atomic number are given to you. This atomic number is going to have 3. This atomic number is going to have 13. Its atomic number is going to have cesium 55. And that of tin is 50. So you know here that this is going to have 2 shells. This is also going to have 3 shells. This comes between 55. So 55 to 55 to this is going to have 6 shells. This is going to have 6 shells, and this is going to have 54. So it is going to have 5 shells. So we'll say that this is going to have the biggest size, cesium, then tin, then aluminium, then lithium. Okay. Cesium, then tin, then aluminium, and then lithium. Got it? Got it?
Yes.
Understood this one?
Yes, sir.
And if the shells are similar, means if we have 2 shells as similar, then what would happen? So we'll use the different things here. So next is if the shells are similar, then what we'll do? Species having inert. If the shells are similar, then the species having inert means the order will be Species having inert gas electronic configuration. Electronic means completely filled shell. Electronic configuration will have the greater size than species having low atomic number. Atomic number means like we have the same, will have the bigger size, and the smaller will be the small species having the high atomic number. Species having high atomic number. Okay, so like we can take an example here, like we have s minus 2. For example, if I talk about this, arrange the following arrange the following in decreasing order of their atomic size. So if I talk about this s minus 2, other one is argon, then one sodium, then silicon, and then chlorine. Okay, so this is the, first of all, this is the charge species. Okay, so if these are charge, other are not the charge species. Okay, then what we'll do here, this is going to have 18 electron, this is also going to have 18, and this is going to have 11 electron, this is going to have 14, and this is going to have 3. Okay, uh, 17 electron. So it will be going to have how many shells? This is going to have 3 shells. This is also 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 going to have 3 shells. All are going to have 3 shells. Got it? So if we have the element, are you getting my point? Here we will compare, because these are the two, they are going to have the same number of electrons. So we'll compare it by using that how many protons are there. So proton, it is going to have 18, and this is going to have 16 proton. So 16 proton, 18 electron. The size of this one will be the greater, because less proton are there and more electrons are there. Got it? Got it?
Yes.
Are you getting this one, Noha?
Yes, sir.
So why silicon sulfide is going to have minus 2, bigger in size than argon? So we know that since we're going to have, this is this one, sulfide will be going to have the greater biggest size, because this is going to have 18, this is also going to have 18. The one which is going to have more less proton but more electron is going to have the biggest size, because the less number of proton are attracting the greater number of electron. So here it is s minus 2. Now if they are the 3 shells, all are going to have the 3 shells, then the inert gas will have the biggest size. Okay, then because van der Waals radius is being calculated, then we have argon. Then after the argon, we're going to have now here the remaining 3 are there. Okay, so we know that the one which is, as we move from left to right, the size of the atom decreases. So you can calculate it. Then we have sodium, then we have silicon, then we have chlorine. Got it?
Yes, sir.
Yes.
If the shells are same, then we can do this one. Got it?
Yes, sir.
Yes.
Last question we're going to take, and then we'll finish this class. Correct order of radius is option 1, selenium, bromine, Br minus, and selenium. Okay, this one is second, bromine, then third one is none of these. Tell me which one is the correct answer. We have here selenium, we have bromine here. Tell me fast.
Option 3.
Option 3. Okay, this, because this is going to have -2, it is going to have bromine form Br minus and selenium form -2. But they both are going to have the inert gas electronic configuration to the nearest noble gas. So if I talk about this one, that how many electrons it is going to have? After bromine, we have here fluorine, then we have neon, argon, and then krypton. Okay, so they are going to have the electronic configuration to the nearest noble gas. Okay, that is 36. Okay, so this is going to have 36 electron, this is also going to have 36 electron, this is also going to have, now this one, they both are going to have 36, but this will be the smaller in size. Why? Because it will be the greater in size. Why? Because the greater number of proton are attracting the less. This is also going to have 36. Now they both, now comparing this one, as we move from left to right, this will be the smaller in size and this will be the, here this is a selenium now. So this will be beryllium here. Beryllium should be here now. And this should be here. So yeah. According to this one is going to have bigger size now, because as we move, yes, it is correct. Third option is correct, because if we are arranging them in decreasing order, so this one is going to have the least size. This one is going to be the greater size. So C is the correct option. You understood, Lena and Noha? Both?
Yes.
Yes, sir.
Okay, so take care. That's all for today. We'll meet you in the next class. And by the end of this, means we're going to finish this chapter by Saturday. Or, sorry, Sunday, almost.